Welcome back to the channel. This video is again on superposition theorem, but this is different from the previous one since I am going to consider the problems which are having dependent sources as well in the circuit. For understanding that how to solve the problems when we have dependent sources present in the circuit, you can check the video of superposition theorem theoretical concepts. The link for the same is provided in the description box. Let's start with the numerical problems. The first one is find the current I using superposition theorem. Now this I current is given in the circuit. The circuit is having an independent voltage source of 17 volts, then an independent current source 1 ampere, and here we have a dependent source. Polarity is marked inside the source. It is supplying voltage 5 times Vx. So this is a voltage dependent voltage source, and Vx is the voltage whose polarity is given its voltage across 2 ohm resistance. This resistance is of 3 ohms. I is the current through this 3 ohm resistance. So this everything is given in the problem. We have to find out the current I. The circuit has 3 different sources. 2 are independent and 1 is dependent. We have to solve this circuit twice since the number of cases for solving the problem are 2, as we have only 2 independent sources. This 5Vx dependent source, it will remain as it is in the circuit. So case 1 is when only 17-volt source is active. So when the source is active, it will remain as it is in the circuit. The current source has to be replaced by its internal resistance, and that is infinite. That's why it is replaced by an open circuit. Here we have voltage 5Vx. Since the circuit is different from the previous one, which is initially given because we have removed this current source, so instead of I will write this current as I dash, and in place of Vx I will write it as Vx dash, because this one is different from what is the voltage over here, and that will be reflected across this voltage dependent voltage source. So it will become 5 times Vx dash, that it will supply voltage 5 Vx dash. Now we need to find out the value of I dash. We can find its value by applying KVL. Also, we need to write this controlling quantity in terms of current I dash. We can say we can apply mesh current. This is a single mesh where current flowing through this mesh is I dash. So we need to express this Vx dash in terms of Ix dash. I dash is flowing in this direction. According to this direction, the voltage drop polarity across this 2 ohm is the lower terminal positive and upper is negative. But the given polarity is just opposite to that. That's why Vx dash is equal to minus 2 times I dash. Since the given polarity and the voltage drop across 2 ohm resistance because of flow of I dash, they are different. That's why it's minus 2 I dash. Then we can apply KVL. So I will start with the 17 volt source. 17 plus 3I dash, that is a drop across 3 ohm resistance. Then we have 5Vx dash, again positive sign came first. Then drop across this 2 ohm resistance plus 2 I dash equal to 0. Now we need to substitute the value of Vx dash over here. 17 plus 3I dash, then 5 into minus 2I dash plus 2I dash equal to 0. When we solve this, I dash is 3.4 ampere. So if we say this is terminal A and this one is B, then it is flowing from A to B. Second case is when 1 ampere source is active. So when 1 ampere source is active, this source will be there in the circuit. We need to replace this voltage source by its internal resistance. Now internal resistance of an ideal voltage source is 0. So that will be replaced by short circuit. So second case is when only 1 ampere source is active. Voltage source replaced by short circuit. Then we have another resistance over here. Now again this circuit is different from the first case 1 when only voltage source was active, and it's different from the initial circuit as well. So this V dash Vx will not be same as V dash or with Vx. Let's write it as V double dash. We need to find out current through this. It will become I double dash. This V double dash is reflected over here. So voltage supplied by the source is now 5 times Vx double dash. Now we can solve this problem by either mesh analysis or nodal analysis. So if we want to go with mesh analysis, then we need to write two mesh equations. This is the first mesh, this one is second mesh, and this will be a case of super mesh. At the same time, if we go with nodal analysis, then we have two nodes. Out of them one is should be reference. Let's consider this as reference, and this one is the node. Since the voltage across 2 ohm resistance is Vx dash, so same is the voltage over here. If this is 0, then this node voltage is Vx double dash. Now let's apply KCL. So current through this 2 ohm resistance is Vx double dash by 2. Then current through 3 ohm resistance is Vx double dash minus 5Vx dash 5Vx double dash by 3. Both currents are leaving, but this 1 ampere current is incoming current, so sum of these two currents should be equal to 1. So we have the value of Vx2 from Vx double dash from here, and that value is minus 1.2. You can calculate that it comes out to be 1.2. We need to find out I double dash. Obviously this term is actually value of I double dash, which is equal to Vx double dash minus 5Vx double dash by 3. So when we use the value of Vx double dash as minus 1.2, I double dash is 1.6 ampere. Again, it's flowing from, if this is A and this one E is B, then it's flowing from A to B. Now both the currents are in same direction. So by superposition theorem, I is equals to I dash plus I double dash. It's algebraic sum of two currents, 3.4 plus 1.6. So I is 5 ampere. Now you need to remember that you can't use the value of Vx dash from first case in second case directly. Some of you might feel like that we already calculated Vx dash over here. Let's use that value of Vx dash in this formula and calculate. That's not correct, since both the circuits are different. In this case we had voltage source, in this case we had current source as an active source. So you need to keep this thing in mind. Now let's consider another problem which will be different from the previous one, since we have three independent sources in this case. Firstly, we have a independent voltage source, then an independent current source, here we have a dependent voltage source, then an independent voltage source again. So in total we have four sources. Current through this 4 ohm resistance is IY. This voltage source supplies 4 times IY. And question is, find the current IY using superposition theorem. Since we have three independent sources, so we need to solve this problem by considering these three one by one. So we will have three cases. Case 1, when only 120 volt source is active. When only 120 volt source is active, so it will be there in the circuit. This 12 ampere current source replaced by open circuit. Then 40 volt source replaced by short circuit. Voltage source by short circuit, since its internal resistance is 0, and current source by open circuit because of its infinite internal resistance. Here we have controlling quantity IY. Now as the circuit configuration is different, so let's mark it as IY1. Then this voltage source will supply voltage 10 IY1. So it's a current dependent voltage source. We need to find IY. We can simply apply KVL in this loop. This is very simple now. So if we start from 120 volt source, minus 120, just drop across 4 ohm resistance, plus 4 IY1 plus 10 IY1, plus drop across 8 ohm resistance, plus 8 I by 1 equal to 0. So this gives us an answer of I by 1 as 5.45 amperes. If this is A and this one is B, then it is flowing from A to B. Then we have second case, case 2, when only 12 ampere source is active. So when 12 ampere is active, this 120 volt source, it will be replaced by short circuit. Here we have 12 ampere source. Then we have current dependent voltage source, 8 ohm resistance, and this last 40 volt source, again it will be replaced by short circuit. Here we have current I by. Second case, let's say it is I by 2, then this will become 10 times I by 2. Now we need to find out the value of current I by 2. Again, you can apply mesh analysis or nodal analysis. For mesh, this will be the case of super mesh. For nodal analysis, we can assume that here we have voltage V, which is with respect to this reference. Then I by 2, that will be equal to 0 minus V by 2. So we need the, sorry, not 2, by 4. So we need the value of V. For that we can apply nodal analysis. So this I by 2 is incoming current, which is having value minus V by 4. So minus V by 4 is an incoming current, plus 12 ampere, again incoming current. Let's assume this current is outgoing. It will be equal to V minus 10 times I by 2 by 8. So minus V by 4 plus 12 minus V equal to V by 8 minus 10 by 8 into the value of I by is minus V by 4. So when we solve this equation, we get the value of V as 17.455 volts. So this will give us the value of I by 2 as minus 17.445 divided by 4 minus 4.36 ampere. So minus 4.36 ampere, it means this one is flowing from B to A, since this one is A and this one is B. Then we have the last case, that is case 3, when 40 volt source is active. So when 40 volt source is active, again this 120 volt source is replaced by short circuit. Then we have 4 ohm resistance, current source replaced by open circuit. Then we have current dependent voltage source. And here we have, okay, we have one more resistance over here. 8 ohm resistance, 40 volt source. This was current I by 10 times I by. Now this current is different from all other cases. So let's write it as I by 3. So it's a simple one loop. Let's apply KVL. Starting from this 4 ohm resistance, we have drop across this and drop across this as well. So plus 4 into I by 3, then we have voltage source plus 10 I by 3 plus 8 I by 3 is a drop across 8 ohm resistance plus 40 equal to 0. This gives us the value of I by 3 as minus 1.818 ampere. So now we found the three different values of I by. Now according to superposition theorem, current I y is equal to I by 1 plus I by 2 plus I by 3. It's algebraic sum of three currents. First case 5.45, I by 2 is minus 4.36, I by 3 is minus 1.818. So answer is minus 0.728 amperes. This is the answer of I by. So it means actually the current is flowing from B to A, not as per the direction which is given in the problem. Here we had taken two problems where we found the current through the resistances using superposition theorem. In next video, I will consider two more problems where we need to find out the voltage across any element using superposition theorem.